Hi, everyone. Thank you very much for joining us today for a webinar on modern DevOps with Docker. It's sponsored by eSynergy Solutions. They specialize in open source and cloud resourcing, pretty much focused in all aspects of product development, particularly focused on DevOps. And my name is, and one thing I forgot to mention there is if you need to get in touch, contact Adele if you're looking for an opportunity around that space. And my name is co-founder and CEO of Shippable. We are a company that has been completely built on top of Docker for the past 18, 20 months. And if you want to reach me, my Twitter handle is @Avinci, and my email is avi@shippable.com. First of all, thank you very much, eSynergy Solutions, for hosting this, and it's a great opportunity for us to talk about some of the learnings that we had with Docker, and at the same point, it gives everyone an opportunity to kind of see interesting webinars. A couple of things about housekeeping. One thing is if you have any questions, just put them through the chat window or the questions window, and I'll try to answer as many as I can towards the end. Second thing, the slides and recording will be sent to everyone tomorrow. And of course, we're looking for any feedback as well as any suggestions for future talk. Just get in touch with Adele at eSynergy. So jumping straight in, this is something that we rally around quite a bit at Shippable is how long does it take to make a small change to an application? And you get very different answers depending on who you talk to. And to start with, whenever you go and talk to a small startup, typically I call them garage devs, they usually say, I can do it right away. And the moment you go and talk to a Scrum developer, they go into this mode of like, hey, we have a backlog, why don't you go put it there, and then we get to it when we get to it. And then you go and talk to somebody in a larger organization, enterprise kind of a mode. Typically, they call that they do Scrum, but it's actually a water Scrum. They kind of say, hey, next release in 3 months. And so the question here that actually pops up is, why does this actually happen? Because it's exactly the same change, and what is causing all these variations? So the key thing that I talk about here is the reason why this happens is usually my experience working with Microsoft for 12 plus years and working on this company for the last 2 years is integration bugs, and it's when your software is built in an isolated fashion is when things start falling apart, and it takes a long time to get this thing going. The usual response at this point of time is, hey, continuous integration solved this, why are we talking about this? There is a subtle difference. The point is that what continuous integration means is at least the way it's implemented today, is that you do one box testing. And what that means is you're kind of doing testing against mocks of all your dependencies. So in this kind of scenario, let's say I'm working on API, I have a mock that gives me UI and the database that I want to connect to, and I do all my tests. But what I'm really not aware of is any changes that are actually happening at the same time on the database also, because my mocks are not getting updated. So when you try to bring all of this together and usually do the functional testing in the end, that's when you start seeing all kinds of variations. And this is where a lot of challenge starts happening because all your resources have started moving on to other tasks, and now you have to pull them back in, and it's a very painful. What you typically see is an infrastructure like this. I mean, this is something that we had at Kinect where I was working at Microsoft, and this was massive infrastructure to get my code base going in. So if you're just one person in a garage dev, you don't care about all of this stuff. When you start having teams distributed across the world, this kind of architecture starts coming into place. And this was one of the main motivation I had for even starting Shippable in the first instance. And even with this kind of a stuff, what we saw was the code quality went up significantly, but over 50% of my time was spent on either deploying, fixing, or stabilizing those different environments. Because what's really happening is each environment is its own silo, and then you're trying to bring it all together in stages, and all of this starts taking time and toll and making it very, very fast. So what I'm trying to really get to is you hear this as an instance, where usually you go from it works on my machine to works on a machine and works on all machines. And that exactly is where the challenge is. So what ends up happening is the cost of actually taking it works on my machine to working on all machines starts increasing as you get further away from the development cycle. And that's what we're really trying to get to in terms of how do we get that as close to the developer as possible. So what that means is the fundamental thing that happens is we need more throughput because 50% of the time we are spending purely on infrastructure management, not really building functions. And so the question that comes out is what do we do? Can we actually think about what industrialization did for the manufacturing line? And so the question is that is software actually a manufacturing line? And the real question that I like to care about is more than whether it is a manufacturing line, it's more of can we make it a manufacturing line or make it behave like a manufacturing line that actually gives me output on a daily basis. So what we started doing at Shippable is we have this concept called jidoka. And what that basically means is you raise alerts when errors occur as close to the source of that error. And I use the word error very, very specifically because the point of jidoka is it's kind of like, if you think about it, it's all, what it is just this. So think of it as a Word document and you're trying to type on it and you make a typo and it immediately puts a squiggly line right under it saying that, hey, there is a typo here. What we're really trying to do is for software to get that for a developer. So as the developers are writing stuff, we want to be able to alert them as close to their writing code itself to say, hey, this is probably not going to work, and so that they can actually fix it. So that's the difference between what I call as an error versus a defect. And so my definition of it is an error is something you discover yourself, and a defect is when somebody else actually finds that there is an error in the system. So what we're really trying to do is to kind of create this jidoka. So if I kind of take the same thing and say, hey, let's take a tier one tier, single tier application, and let's call it API. Usually you have a master branch that sits on some kind of a source control. What typical Git-based development workflow is, hey, you fork that particular thing. Let's say I'm developer D1, I fork that into an API, and now I have my own copy that I can make changes on. Now I make changes, I figure out it all works on my local machine, I push it to my fork. Now what it means is now I need to run a CI system running on that particular fork. Now if that passes, now I do a pull request back to the master, which actually fires another CI, which is taking the current state of API master, merging it with the new state of the fork, and running a CI without actually merging it in real. I mean, it's not actually commit-based merge, it's PR-based merge that you're doing, so that it's still not yet fully committed into master. Now, if that passes, you can actually commit it and then push it to your beta or pre-prod or any of those environments, which actually fires another CI process to make sure everything worked. So if you look at that, there are three different CI that's happening here. One is against your fork. The second one is the intention to make a change to the master. And the third one is after the change has been committed before it pushed into pre-prod. And then if it all works, you can push it to prod. Now, if there are two developers working, it looks something like this. And it's pretty much the same concept. It's just that the second developer has their own CI built on that particular fork. What is alarming in this one is you actually need three different dev CI processes and one for pre-prod. And this is all good, but the moment you go into a more serious application, let's say a 3-tier application, what that means is I now need 21 different VMs. So 18 dev labs, which is, think of it as, the way the simple math on this is 3-tier, each developer gets 3 VMs because you need to do functional testing, not unit testing. I have 2 developers per gives me 18 VMs, and then 3 for pre-prod because I have 3 machines, DB, API, and UI. Now, even if I go and say I'm going to get some kind of like a cheap machine on Amazon, pay 15 cents an hour, we are still talking about $2,300 a month just to do a 3-tier application in a jidoka fashion. Now, even with this, the problem is I still have tons of VMs. I have tons of Ruby code, assuming I have done all kinds of DevOps automation using whatever DevOps platform you're actually using. And even if I have done all of that, I don't get portability of VMs because I'm redeploying on every single step. And then every single time you have to bring up this whole environment to reduce your dollar cost, you're talking about 30 to 40 minutes of spin up, build time, all of that process happening. So you've still lost a lot of productivity and increased your dollar cost. What you have done is solved all the bug problem being found way late in the game. Now this is where we started looking at how do we actually take this concept of VMs out and try to use something much more lightweight during the early stages of process. So where containers came into rescue when we started looking at this back in 2013 was you had this whole promise that I could actually build once and run it anywhere. The second thing was I didn't have to write any Ruby code for doing app deployment. I needed Ruby code to bring up my basic infrastructure, but that was all available freely, and there was nothing else I was doing on top of it. And the most important thing was it took me less than 10 seconds to actually spin up a container, not the 15-minute VM deployment that was happening in my traditional thing. And the most important on top of that was it was layered images. It was not like where I started from scratch every single time. I could actually create base images that are built on top of each other. So overall, I got reduced build time. So I got reduced build time, faster spin up, and it is lightweight containers, and I didn't have to write Ruby code that I needed to manage all of this. And the most important thing was I could actually run this anywhere. I could build it on my laptop and then run it on AWS or run it on Azure or run it on any cloud that's out there. So the container workflow looks something like this. It is basically you have a yard. It's a Docker registry. It could be Docker Hub. You could be running your own infrastructure. You need some kind of a continuous delivery platform that handles containers. Now, of course, I've called it Shippable here, but you could use anything out there. The key is that we are built natively for containers, so it's a little easier if you use us. And then what you now do is create a dev shipping lane for your API. So now what dev says, they create a Docker file that actually enhances whatever base image you want to use, whether it's Ubuntu, whether it is CentOS, whatever you want to pick, you create that base image. And then you enhance it on top of it with whatever packages, whatever special settings you want on top. And then you write your code, and both of it is pushed to, I'm using GitHub here, but you can use any kind of source control out there. Now, the moment that happens, it actually triggers, like I'm making changes for API. What it does is it goes into the yard and says, give me the latest version of my DB, give me the latest version of my UI. I'm going to spin up those two containers along with the newly created API container. Now I can run a full end-to-end test against real services. I mean, people usually call this functional testing, not just unit testing. This is more functional testing. And then once I'm ready, I can just now push that API final image back to the yard and use that to deploy to pre-prod, where I'm not actually redoing any of this stuff. It's just basically I'm doing a simple thing called Docker run. And then I can push that to a prod, and all it is about now is about how many scale units of API do I need. So the advantage I get here is it's an immutable image that I can use it to deploy anytime, anywhere. Like a simple thing is I could pretty much go to exactly, let's pick an arbitrary date, let's say December 25th of 2014. I can deploy my entire infrastructure to look like exactly what it looked like on December 25th without even having to change any of my infrastructure. It's one click, within 10, 15 seconds, my entire infrastructure will roll back to December 25th. So you get this advantage of one click roll forward for upgrades or one click roll backwards for any kind of things that you want. So what you get is a lot of flexibility in terms of trying out and experimenting on top of this architecture. So if you look at how we built Shippable, I mean, this is the architecture that we are currently running. And what the key thing here is every single block that you see, like let's say image pull, image build, or GitHub, Bitbucket adapters, all of this is a microservice. So we are running, I don't know, like in this scenario, I mean, on this page, just by estimating it, we're talking about like 30, 40 different microservices that we have built. And all of this run independently on GitHub repositories, and all of this has its own image on the Docker Hub. And so what we get in this kind of an architecture is I can make a change anywhere in this entire infrastructure, small micro functionality that you're trying to really go for, and then you can immediately push that into a pre-production environment and test it in real time, as opposed to waiting for this entire monolithic application to get deployed in one shot. Now, of course, not all applications are built this way, but the hope is that you can start slowly carving out pieces of it over a period of time and move some of the big monolithic applications into more manageable chunks out there. So that's what we are really, really trying to drive and kind of create that. So this is a slide that is super critical, because what this is giving you is some of the things that we believe in future, the architectures of how applications are going to be developed. And one of the main things that is very critical in this kind of an architecture is having an orchestration layer like a message bus. So every single thing that is talking doesn't even know, like for example, if I look at the pre-CI world, there is an image pull, an image build, and an image boot. There is, when an image pull is actually running and it needs to go and tell image build to run next, it doesn't even know that image build exists. All it does is fires a message to the message bus. Image build is listening to that message bus, and then it gets a request and starts spinning image build out there. And then that is basically gives you complete flexibility. Now you could run versions of image builds, different versions talking to different layers of the message bus. So what you're really trying to get to is get innovation done as fast as possible, or evolution of your architecture done as fast as possible. And all of this is made possible by having lightweight containers as opposed to using VMs for each of this. I mean, if I had proposed an architecture which needed this many VMs to run, people would have looked at me and said, that's impossible for us to actually manage because we are too small of a company to run this many VMs. So that's where the value of Docker comes to us. So if I kind of take that architecture and look at the customer impact or container impact at Shippable. So this was how it looked for us. We were 21 VMs running a simple 3-tier application at that point. We were paying $2,300 to AWS, and this was not our production hosting. This was purely DevLab hosting cost at AWS. And then every single time anything made any change, our end-to-end build time from start to finish was about 30 minutes. This included machine deployment, packaging, testing, and then actually bringing it up into pre-prod to actually run functional tests. So now what we have right now is we dropped that down to 3 VMs. So of course these 3 VMs are bigger than the 21 small VMs that we had, but the advantage I get is it's more like a fabric that gives me CPU, memory, and network, and I can actually spin up as many containers as I want on top of it. Now, we of course went from 15 cents an hour to a 42 cent an hour machine, and that brought it down to about $900. And our spin up time, including our build time and everything, was 10 minutes. And we could spin up any and so even though if you just plainly look at these numbers and saying, yeah, that's a good 70% cost reduction, but that was not the main thing that we saw. The key thing was we didn't have to manage 21 VMs anymore. All I had to do was manage 3 giant VMs, get the basic infrastructure laid out, and then everything was just containers running on top of it. Of course, we had to solve networking and some of the stuff that a lot of people are now talking about in Docker, but the basic problem was that basic issue that we were after was we need not have an operations team managing 21 VMs, patching it, upgrading it, and all of that stuff. So, of course, if you look at that, it is a small container, and what it did is over 60% of my infrastructure cost was reduced. And not only that, I get increased productivity, and that is because I can now go towards breaking down my application into small self-contained containers that I could use independently. that now a single code line or any change I make to any single application could be got to my end customer's hand much faster than anything that we had done in the past. So it is definitely a giant leap in terms of how we think of it. So if you look at the ability for me to say, like even 2 years ago, with the amount of resources I had at Microsoft, where just our lab cost on Kinect was about $5.6 to $6 million of infrastructure just in the labs. Even with that, it took us anywhere between 7 to 12 days before we could get code change into actually make it into something like a pre-production environment. In our infrastructure at Shippable, where we are running probably 1/500th of the cost of infrastructure, we can actually get something out there into production in a reliable, enterprise-grade level way in less than a couple of hours. And that's a huge possible because of the confidence that we have an immutable container. I'm going to push it out there, and I'm going to take 10% of my traffic and route it through this new container for that particular microservice. If it doesn't work, I immediately roll back to my prior version of the container. Or if it works, then I start accelerating the deployment from 10% to the rest of the 100% of my traffic. So I get a lot of flexibility from an operation. So now think of it as what we are getting now with this kind of containers and microservices architecture is, as an operations person now, you are managing more of the state of different containers and microservices and what rate of deployment into production are you making, as opposed to actually going and sitting and trying to get network and all of those pieces deployed every single time. So that's pretty much my presentation. So my tips from a DevOps perspective, I want to try to take questions because there's quite a few questions out here. Or DevOps is basically this. First is keep it timely. So our whole goal has to be about efficiency. A lot of times DevOps gets into a conversation of who has to do what. I think the conversation should be tipped around, for lack of a better word, into whether it creates efficiency or not. Because what we believe at a very fundamental level is companies that can actually evolve fast are the companies that will survive. And the future is going to be many pieces of stuff that doesn't run software today will all be running software, like tables, chairs, plates, everything will run software. So if we can't create efficiency, we'll create a huge log jam in terms of how to bring software out into the market. The second thing that this is one of the most important tenets that we have at Shippable, is every single piece of your software needs to be isolated. And containers gives a very clean way of doing this. And what that means is a particular piece or a particular microservice has to be about, hey, I don't care who's before me or who's after me. I only care about, I know one thing, and this is how I actually do it. And the third thing is it's about portability. So even though AWS is a big cloud, there's a lot of people using AWS today, there's still a lock-in in AWS. So you're kind of trying to lock in into one kind of a cloud architecture. So what containers or Docker in general gives you is that ability to say, hey, today I'm going to be running on premises, running VMware stack or KVM stack, and I suddenly saw that my load is actually going up, and you can easily move those container workloads onto AWS. And then once you see that load coming down, you can come back onto your on-premises. Or you could be on AWS, Google, and Azure. So Shippable today runs on all these three clouds. And we for running on AWS versus Azure. It's the same exact thing. Of course, the underlying VM provisioning is different, but we don't do that all the time. We do it once in a while. And of course, you want to make sure your code is always deployable. We call it shippable. The key is this is the scenario where we used to have a lot of discussions, right? I mean, you don't want to be running and scampering if suddenly somebody in the business says, hey, I want to be able to set up a demo for tomorrow, and I want the latest changes, all the stuff that we have been working on, I want to demo that. we shouldn't be scampering to kind of go create an environment for it and trying to deploy and bringing all of that stuff. What it needs to be is more of like saying you already have an environment and all you're giving is a role access to see some of the changes that have not yet been publicly released yet. So like, for example, I'll give you the extreme at which we do development at Shippable, right? We don't have a beta environment. We don't have a dev environment on a common infrastructure. And it's just routing of traffic that actually allows us to say, hey, beta traffic goes to this particular service, whereas production traffic goes to this standard production service out there. So think of it as, let's say I have an authorization component, and I'm supporting today GitHub and Bitbucket, and for some reason we need Google also on top of it. We will have two different authorization services. If you go to beta.shippable.com, it allows you to log in with Google because it's going through the OAuth microservice that has Google along with it. And then whereas if you go to shippable.com, it will go to the production auth service, which only does Shippable and, which only does GitHub and Bitbucket. And whenever we are done and we feel that my beta service is up and running, all we're going to do is replace the production container with the beta container, and that becomes production at that point of time. So I think it's a huge deal from that perspective of managing this whole infrastructure. So if you don't remember any of the stuff I talked about on the slides, all I would say is takeaway is remember tips, make it timely, make it isolated, make it portable, and keep it shippable always. And that's pretty much. And of course, if you want to try out our product, it's free, so you can try it out. And I'll try to answer some of the questions out here. So the first question was, I don't understand the performance overhead using Docker versus putting an app directly onto a server. It seems like the app needs a virtual server sitting on top of a server, so a layer of overhead. Actually, this is an excellent question. So think of it as this, right? Basically the question is, why do I need a VM on top of a machine in order to run Docker? Because if you have to need that, then you're going to lose performance. I think that's the point of this question. So what actually it means is, at that point, there was no operating system level for just purely containers when we were running containers. So the only way we could run it was we needed access to the kernel somehow. So what we used to do, the thinnest operating system of Linux that we could get deployed, and then run containers on top of it. And ironically, of course, somebody else figured out the same problem, so now we have multiple options. Red Hat is shipping a product called Atomic, which is a super thin, lightweight, I think it's 35 megabytes, if I'm not mistaken, of an operating system that sits directly onto bare metal, and the only thing it does is run containers. CoreOS is another product that you can actually use also to do the same thing. So I absolutely believe that in the next 3 to 5 years, very few people will run VMs. Everybody will be running this lightweight ESX equivalent for Docker, and then run Docker containers on top of it. And this is an excellent question. The second one, are the slides available? Yeah, I did mention up front that both the slides as well as the recording will be available tomorrow from eSynergy Solutions. We'll send it out to all the attendees. Other question, what is your advice for running Docker on top of VMware? So as I mentioned, right, there is some advantages for VMs as of today. One is it's a hardened technology, which a lot of people have run a lot of different stuff on it for over 10, 12 years now. So I think there is the risk to reward ratio currently is still tipping towards, hey, run a VM so that you can predict what your base operating system and base operations in terms of networking, everything is happening, and then run containers on top of it. So absolutely you can run on top of VMware. We have run it on all of it, VMware, KVM, Xen, and it runs pretty much fine. But we do think that over a period of time, people will start moving away from VMs, whether it's from VMware or whether from any other VMs, into more of that runs containers naturally. like CoreOS or Atomic, and I don't know what in the future is going to be. So one question, do we run on soft layer? You mean shippable? Yes, we do. What we basically have two versions of our product. One is the multi-tenant host where we manage the hosts. The second one is what we call as dedicated hosts, or BYOH, which is bring your own host. So at that point, all we care about is can we SSH into that machine, and it could be anywhere. It could be on your premises running VMware, or it could be running on soft layer. Again, on soft layer, there are two things, whether it's a VM on soft layer or whether it's a physical machine on soft layer. If it's a physical machine, we need something like CoreOS or Atomic running on top of it so that we can actually talk to it. Third one, how do you manage database data structure changes in deployment? Like, this is another very, very good question. So this is the fundamental problem that we have databases, right? Because when you're changing data structures, you're altering the way data actually looks like. So it's a hard question to answer. The way we do it at Shippable, I can tell you how we have done it. So the way we have done it is, first tenet we use is it has to be fully restable. That basically means you can't use any kind of joins or anything in terms of data manipulation. So if you do that, then you are at a much better state of achieving continuous delivery with databases. So the second thing that we do is if you're using structured SQL-like thing, it becomes a little bit more challenging. But if you're using NoSQL-based JSON-like objects like MongoDB or even Postgres, if you're using the BSON objects or anything like that, you can actually extend the architecture, extend your data structures without having to change all your prior data sets. So it allows you, like, otherwise, if you're doing traditional SQL, which we used to use SQL Server at Kinect, what we used to do is all our data was actually versioned. So we knew when queries were coming in, what version of the data is this query actually coming in. So we would never make updates to a schema. We would actually create separate schema as we upgraded. And then when people started moving around, we would actually allow them to switch different versions. So it's always one-way upgrade. You can't go back to the prior version. But if you can structure, first is if you're fully restable, then you can achieve this much better. The way it will work is scenario would be, let's say you log in into some UI. The UI will say, hey, you are in version 3.1. Do you want to upgrade to the latest version 3.5? And then when you hit OK, what it does is the system does a live migration of your database into the newer structure. And after that, you're always on 3.5. You can't go back to 3.1. But again, it's not as easy to use a container to do versioning. It's more of like you need to make sure your architecture supports that kind of a question. The next one was, how can we approach business to change the current VM infrastructure to Docker when we depend so much on the IT infrastructure decisions? So I don't have a prescribed solution for it. This is much more of it's much more of the culture of the company and how they think of it, right? So the best way I would suggest you could do this is you start abstracting yourself out from the machine. So one of the things that you could potentially do is you say that, hey, we need these VMs deployed and these are the basic requirements for the VM, and you still deploy Docker on top of it to manage it. So you are not really going into an IT politics battle at this stage. So first is to get your entire engineering a container-based technology, because there's still a lot of work that you will have to do even from a developer perspective itself, right? Even now, we have been doing this for 2 years. We have written a lot of tenets of how to actually do this in a container-based development. But when new people join us, it takes them at least 3 to 4 weeks for them to really understand how to do development in a container-based environment. So I think I would not fight the IT battle right now. I would just first create value for your overall organization by making sure that containers are the right things for you to do. And then once you see value, you can have a data-based, or lack of a better word, data-driven discussion with IT to help them see the value of what they get. And the simplest thing would be is, look, I mean, if I have a massive application, you're managing, let's say, 200 VMs, that is all going to get reduced to 15 VMs, and we'll still the same level of subnetting, all of that stuff, because we can group things to microservices. So why would you want to run 200 machines and manage all the patching on it? So it should be more of a value-driven discussion as opposed to saying, hey, let's all switch to Docker tomorrow morning, right? I mean, I don't think the technology is there yet for big corporations to adopt right out of the gate. But I think for startups like us, where we are actually looking for that edge to change the cost equation, it's a huge deal for us, and then that's how we think of it. So do you see a performance impact from doing so? I think this is assuming, I'm not sure which question. Oh, we are considering to run Docker on top of VMware infrastructure and would be very interested in this. So is there a performance impact? I don't think that there is as much as it depends on how your VM is structured. So what you will see is, I mean, we were running on purely VMs. The main problem we used to have was suddenly now what you're doing is you're adding, let's say, 20 containers running on a single VM. And all 20 are, and we are using microservices architecture, which basically means it needs network. So what we started seeing is we started seeing network saturation a lot more than actually performance hit due to RAM or CPU or disk access. And so I think if you want to do it with VMs, I would strongly suggest that you want to think about your network interfaces, not just virtual network interfaces. I mean, think of it as the main problem you will have is your VM itself is already running a virtual interface, and now you're running 20 containers on top of it, which is 20 virtual interfaces on a virtual interface, which is sitting on the physical NIC that's sitting on the host machine. So one of the things you could do is, what we used to do on Amazon was best possible VM on Amazon. And at that point, we knew that there would be nobody else on that VM, and so the NIC was belonged to us, so we don't get network saturation. But if you're doing it yourself, just make sure that you have enough NIC cards on the host machine, physical NIC cards on the host machine, so that you can actually do it. I think that's the one thing you'll probably hit network saturation before you hit anything else. So is Docker supported by Windows, and is there any thin OS on Windows based? I'm guessing Windows Core, but wondering if there are better solutions. So there's been a lot of talk from Microsoft's perspective about container system. Docker and Microsoft are very closely working towards it. I don't think that they're working on a thin OS. What they're really doing is they're going to probably add, I mean, this is my personal opinion based on all the blogs I'm reading. I don't have any data from Microsoft or Docker, so take it with a pinch of salt. They are going to potentially add libcontainer, which is the kernel interface, into the .NET layer, so that you can actually run Linux-based Docker containers natively in Windows. I think that's what they will do first. And that basically means that you can pretty much get rid of VMs completely, just take a physical machine, install Windows the way you were installing it in 1999, and once you have that, now you can spin up as many Linux containers as you want on top of it. I think that's basically what it is. And I don't know, unfortunately, I stopped working on Windows for the last four years, so I don't know much about Windows Core. I know that it's a GUI-less stuff. I don't know whether you can run .NET on it or not. If you can probably use Windows Core along with this kind of a technology that could be much thinner and lighter than the traditional Windows Server. Do you think Docker would help regression testing in Selenium? Exactly. I mean, that's exactly what we do. A ton of folks on our system run Selenium-based tests Much more than that, what they're actually doing on top of our platform is they're running Selenium-based tests for different aspect sizes, like let's say Android and tablets and iOS, all kinds of sizes. Screen sizes are all different. So what they do is they use Selenium to basically do UI-based testing, and then they take screenshots of all the different pages before and after, and then they compare it to see how that change affected all the different aspect ratios running on top of us. I mean, this is the beautiful part of running a cloud-based service is I can spin up all of these in parallel and I can get all the results together as opposed to running it on my own laptop or a small server that we have as part of the build. Yes, you can absolutely do this. How difficult is it to get set up network and load balancing on the servers within the cloud without being IT? Dev view terms. So I'll tell you from my perspective, I am not an IT guy. I didn't even understand networking before I started doing this. So, and I think that it's pretty straightforward, and it's not very, very difficult to get all of these things working, especially if you're doing it in the cloud. AWS gives you elastic load balancers that are pretty straightforward to configure. If you want to do some advanced stuff like certificates and everything, you need to know a little bit. But if you want to send me an email, I'll be more than happy to send you our deployment document for the AWS pieces of it so that you can actually do it yourself. It's not very, very difficult. Previous question related was network in Docker containers. Oh, okay, sorry. So Docker containers have improved significantly in the last 3-4 months. So they're giving you all kinds of options for network containers. So if you have your physical machine networks all set up, pretty much do a lot of things in the Docker run command that allows you to do this. So the biggest challenge that you will have is port configurations, because all of your containers, let's say you're running a web app running Nginx for simplicity, it's running on port 80. All your containers will be running port 80. So if you run 10 copies of that container on your machine, you can't use port 80 of that host machine. So you'll have to somehow create mapping of the ports. Let's say you start with something like, let's say 20,000, and you go from 20,000 to 20,010. Now you need to somehow tell the load balancer that these are the new ports on which my containers have come up so that the routing actually happens. Now that one requires a little bit of automation, but it's not very, very difficult to do. So the way we do it is we have a Redis server that has name value pairs. And what we do is whenever a service starts up, it actually publishes a message to a Redis server. Say, hey, UI 235 started on port, whatever, 20,008. And this is the IP address of it. So now that is the master list for all of our services, and we have an automated update into load balancer so that you don't need to really do this manually. But if you do CoreOS, HCD will help you to do a lot of these things very, very easily. But CoreOS is a little bit more challenging. You need to know a lot about CoreOS, how it actually works in order to use it. It's not yet at an AWS level of utilization. So it shouldn't be very hard. You should be able to make it work. Again, send me an email if you need more information. I'd be more than happy to share that. So does Docker invalidate the use of configuration management tools like Puppet and Chef, and how so? Now this is a touchy question. I'll try to answer it without the Shippable's perspective, right? And the way you think about it is Chef and Puppet and Ansible or any of this stuff, right? What they are used for is configuration management of infrastructure. Trying to do application management also in this means that you're trying to fit a square peg into a round hole. Now, can you do it? Absolutely. Like, if I'll give you a simple example, right? In Microsoft SQL Server, there used to be this thing called assembly execution, which actually was C# coding on top of a database. So you could potentially write your entire application just on a database and never even have any app server. So the question is not whether you can do it. The question is more of like saying, is that the right thing to be doing, is what I would ask, right? So my personal best practice is the application configuration of how an application runs and how all of that happens needs to be part of the application, and how the infrastructure is deployed needs to be part of the infrastructure. You use Chef to do both, or whether you use Puppet to do both, it's completely left to your choice. Each one will come with its pros and cons. And my personal thing is I wouldn't do application configuration management on a Chef or a Puppet, basically because I don't want to learn Ruby. I mean, my whole application is written in Node.js and Go. So why am I learning Ruby? And now why am I having another set of code base to manage my application settings? I don't care about the infrastructure, how the VM came up, or how the networking switch was configured, how the load balancer was configured. I'm less worried about that. But just in a microservice kind of an architecture where we ship to production about 70 to 80 times a day. And when you're doing that, and every time I have this other code base which is not native to most of my developers, is a challenge for me. So it's more from a personal choice. But if you're building all Ruby application end to end, now that might be okay for a lot of folks. So that's how I would think of it. Question or not, but I think that's the best I can do right now. I was late to the seminar. What is my email? My email is AV as in Victor I @shippable.com. I should have probably put it on the last slide also. It's avi@shippable.com, or you can tweet to me, and it's Avinci, AVINCI, as my Twitter handle. So, what are the recommended ways to monitor Docker containers and scale resources based on that? So, I mean, there's a lot of technology that's coming up right now around the space. There is Mesos, which is supporting a lot of this stuff. Google just open sourced their entire infrastructure that they were using internally, and it is basically called Kubernetes, Kubernetes, and it's a pretty rich platform for doing exactly what you're talking about. So the beauty of Kubernetes is Kubernetes automatically deploys an HA proxy instance for any one of your microservices. So if you say, I have a microservice, let's call it credit card processing microservice, right? And for whatever reason, you had a fantastic holiday season and you're getting 10,000 calls of credit card authorization and your service only handles 2,000. Kubernetes automatically scales your containers to 5 and tries to manage that traffic, and without having to worry about any of the networking, because it's all behind an HA proxy instance, and so it's automatically load balanced. So every time you deploy more than one container for a particular microservice, it automatically puts a load balancer in front of it, and then you can use the load balancer's IP address to put it on the actual edge load balancer so that you don't need to change it again and again and again. So Kubernetes we have completely switching over to Kubernetes. I'm not basically endorsing something that you should absolutely look at, and that might be helpful. So that's pretty much all the questions I had, and if you have any more, feel free to send it over to me, or you can send it to Adele, and I'll try to do my best to handle it or answer it. And I hope it was pretty useful, and thank you very much for joining us, and as I said, you'll get the slides and the recording tomorrow. Cool. Thank you.